Hello, grade 8 learner, and welcome to our math video lesson, where we will be discussing how to identify the congruent pairs of parts to prove that two triangles are congruent under the SAS postulate. This lesson is based on the K-12 curriculum learning competency. The learner illustrates the SAS congruence postulate. It's another great day to learn, so prepare your pen, paper, and module as you start watching and learning from this video lesson. Refer to your Quarter 3 math module entitled Triangle Congruence Postulates for this example. Let us name the corresponding congruent parts of the following triangles to satisfy the SAS congruence postulate. Let us observe the figures given. Because we are given that triangle ABC is congruent to triangle RST, we can identify the corresponding vertices in the triangles. This is important so we can name the corresponding congruent parts correctly. From the figure, we can see that the vertex A in triangle ABC corresponds to vertex R in triangle RST. Following that, we see that vertex B corresponds to vertex S, while vertex C corresponds to vertex T. Let us process what we know. To be able to name corresponding congruent parts in the congruent triangles, we first define what the SAS triangle congruence postulate is. The SAS triangle congruence postulate states that if two sides and the included angle of one triangle are congruent respectively to two sides and the included angle of another triangle, then the two triangles are congruent. This means that to prove that the two triangles are congruent, we only need to identify two sides and its included angle in one triangle and prove that they are congruent to their corresponding sides and included angle in the other triangle. Let us solve the problem. To begin satisfying the SAS congruence postulate, we first identify two pairs of congruent sides in the triangles. Given the triangle ABC is congruent to triangle RST, we name the sides following the corresponding vertices. Thus, line segment AB is congruent to line segment RS, and line segment AC is congruent to line segment RT. We now name two pairs of congruent sides. However, this pair is not the only pair you can use when showing that the two triangles are congruent by SAS postulate. We shall show other alternate pairings near the end of this lesson. After identifying two pairs of congruent sides from the triangles, we identify the included angles in the triangles. To identify what the included angle is, we look for the angle between two sides of the triangle. In triangle ABC, we identified line segment AB and line segment AC. The angle between these two identified sides is angle BAC. This should be congruent to the angle between line segments RS and RT, which is angle SRT. Thus, we have the statement angle BAC is congruent to angle SRT. Now that we've identified two congruent pairs of sides and two congruent included angles, let us state our conclusion. To satisfy the SAS congruence postulate in proving that triangle ABC is congruent to triangle RST, We name and mark using hash marks. First, a pair of congruent sides, which are line segments AB and RS, a pair of congruent included angles, BAC and SRT, and another pair of congruent sides, line segments AC and line segment RT. Identifying these pairs of congruent parts proves that triangle ABC is congruent to triangle RST by SAS postulate. The answer previously given is not the only answer you can make to satisfy the SAS congruence postulate. Take a look at the following alternate answers for this problem. As long as there are two pairs of congruent sides and their included angles that are identified in the two triangles, the conclusion remains to be triangle ABC is congruent to triangle RST by SAS postulate. Congratulations for finishing this video lesson. Now apply what you've learned by answering the activities in the activity sheet. Happy learning! We'll see you again in our next video lesson.